But yeah, let's go ahead and get started, guys. So here we go. Last day. So hopefully you guys remember, and I don't know if this is part 3 or part 4. I already lost count. If you count the differential equations from before spring break, then if you count that as number 1, then it would be part 4. If you do not count that as number 1 and you just count the lessons that we've been doing during intersession, then it's part 3. So I don't know, part 3 or part 4, just call it differential equations. So hopefully you remember not all differential equations are separable. So check out notes 37. And here's the question that a lot of kids thought was a hard question in 2015. So let's see if we can do this one, guys. So in the axis provided, sketch a slope field for the given differential equation at the 6 points indicated. So I'm just going to go a point at a time. At 1, 1, 2 times 1 is 1, 2 times 1 is 1. 2 times 1 is 2, 2 minus 1 is 1, so a slope of 1. And if you go to 1, 2, 2 times 1 is 2, 2 minus 2 is 0, so that's a slope of 0. So we took care of those two. So now I'm at 0, 1. 0 minus 1 is a negative 1, so slope of negative 1. And then 0 minus 2 is negative 2, so slope of negative 2. So there it is. I think that's correct. Now, if I go to 1, negative 1, that should turn into 2 plus 1, which I believe is 3. So there's 3. And if I go to 0, negative 1, that's a slope of 1. So I believe that's correct, guys. If I made a mistake, which I do all the time, let me know. I haven't gotten much sleep. I'm sure you guys haven't gotten much sleep either. But it's okay. It's okay. We can live. We can move on and continue living the good life. So here it is, guys. Letter B. It says find the second derivative. That's what that means, right? D2y dx squared in terms of x and y. Determine the concavity of all solution curves for the given differential equations in quadrant 2. Give a reason for your answer. So I don't know why a lot of kids thought this question was hard. They already give you the first derivative. So let's see, dy dx. Let's see where people are having issues. Dy dx is 2x minus y. All right, so this means take a derivative with respect to x. So I'm going to write d2y dx squared. Now, hopefully you guys don't need a review on that. That just means d dx of dy dx. See, second derivative. So take the derivative of this guy. So that's where you get the 2d's over dx squared. And it's understood that it's that. But that's just a side note. Don't write any of that. I mean, we should know that, right? Okay, so let's see. Take the derivative. The derivative of 2x is 2. And then the derivative of y with respect to x is dy dx. Do not leave it like that in terms of x and y. So we're going to go write 2 minus, and I write back what dy dx is. 2x minus y. If you want to leave it like that, that's okay, I think. I'm going to go ahead and distribute that. 2 minus 2x plus y. And then I'm going to do a little sketch here. Not a big sketch, just a little one. And quadrant 2, I hope that everyone knows that this is quadrant 2 right here. And in quadrant 2, my x's are all negative, because all x's are negative. Don't ever go back to an x. X's suck. I was trying to be funny, but it probably wasn't funny. And the y values are always positive. All right, so knowing that, so let's see. The second derivative, which is 2 minus 2x plus y. And then we know that x is always negative and y is always positive. So let's see. 2 minus 2 times a negative plus a positive. Will this always be positive? Check it out.
Yes.
Yeah, negative 2 times a negative, that right there that I'm circling in blue, that's always going to be positive. Do you guys see that? So because I have 2 minus, 2 plus now, a positive, plus a positive, this will always be positive. So I'm going to write concave, I guess I should write a nice sentence. Determine the concavity of all solution curves in differential equation quadrant 2. So I'm going to write all solution curves. Let me write it in blue. All solution curves in quadrant 2 will be positive. Erase that. All solution curves in quadrant 2 will be concave up. Concave up, since the second derivative is always positive in quadrant 2. There it is. I think that's full credit. The author or the reader can see that you wrote that x is less than 0 and y is greater than 0 for quadrant 2. They see that little work down here, and they see that that's always greater than 0. Perfect. You got it. Do you guys feel fabulous? Okay, good. All right. Here we go. Letter C. Let y equals f of x be the particular solution to the differential equation with the initial condition f of 2 equals 3. That's a point. Does f have a relative minimum, relative maximum, or neither at x equals 2? All right. What we got to do, we need to figure out first and foremost, do I have a critical point at x equals 2? Is this even a critical point? How do I figure out whether I even have a critical point?
You equal the derivative to 0.
Yeah, equal the derivative to 0. Because, guys, the only time you have a max or a min is if the derivative is 0 or if the derivative is undefined. Look, that's the only time. Min, max. Oh, Chavez, what about undefined? Well, it looks like this if it's undefined. I guess I'll do a V there for that one. That's a max. And then I'll do like a parabola with a linear line. That's a min. See? So the only way you get a max or a min is if the derivative is 0 or if the derivative is undefined. Are we clear? We have an expression for dy dx, and we have an x and a y. So let's see if my derivative is 0. So dy dx is equal to, and I already forgot the equation, 2x minus y. 2 times 2 minus 3. I guess what I would have also done, I didn't do it this time, but I have a habit of usually putting that line in there. They would not take off points if you don't do that, but it would be nice if you did. Dy dx evaluated at 2, 3 is, let's see, 2 times 2 is 4, 4 minus 3 is 1. No calculator. These questions usually don't have a calculator. There it is. Do I even have a critical number at x equals 2? No. So you're just going to write neither, since at 2, 1, dy dx does not equal 0, period. And there it is. That's full credit. You don't even have to say 2, 1. You could have said at x equals 2 as well. Oh, I got it wrong already. Okay, be careful. I wasn't there for this question, but I wrote a wrong statement, but with the correct logic. That is a reason to not give you the point. What did I write wrong?
You wrote 2, 1.
I wrote 2, 1. That is false. That is a false because look, at 2, 1, I mean, well, I don't know. At 2, 1, it might be 0, but they're not asking about 2, 1. They're asking about 2, 3. So it might actually be a true statement, but you always want to make sure to give the true statement. The truest truth. Does that even make sense? The truest truth? Is this even a critical point? Nope, not even a critical point. Neither, since at 2, 3, dy dx equals 0. To play it safe, I would have probably said at x equals 2. But no big deal. That's full credit right there. All right. Here we go. This one, I did look at the rubric, so I'm not going to lie to you guys. I do not like the rubric on this question. I will probably delete that because I work for ETS and I want to keep getting hired to grade AP exams. I don't want them to judge me. The answer that they have on the rubric, I would never have even thought of going that route. I would never have thought of going that route. The route that I'm going to do, I'm thinking, The route that I'm going to show you guys, I think would have gotten full credit. I'm pretty sure. I can't believe they put the answer that they put on the rubric. I'm assuming that's what most students did, but I don't see most students doing that. So letter D says this: find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation. So the way my brain works, the way I work, if this is a solution, and I just got finished, well, I did dy dx, but I just got finished up here doing the second derivative. Tell me something about linear line and the second derivative. I mean, I don't know, maybe kids don't think like this, but that's the first thing I thought of.
Doesn't it like not have concavity or something?
Perfect. Yeah, that's exactly correct. If the second derivative is positive, you're concave up. If the second derivative is negative, you're concave down. But if the second derivative is 0, that means you have a linear line, no concavity. Linear lines do not have concavity. So that's how I was thinking. And I'll show you the rubric in a little bit. So the way I was thinking, I was thinking this. I'm going to write what I'm thinking. I'm going to say, since y equals mx plus b is a solution to the differential equation, comma, that's an n there. We know that the second derivative must equal 0 since y equals mx plus b is a linear line. That's how I think. So immediately I just go, what's my second derivative? Here it is, 2 minus 2x plus y. So I come over here and I go, second derivative equals 2 minus 2x plus y, and that must equal 0. And then immediately, the way I think, I'm like, oh, look at that. I have an expression in there. And immediately I'm like, hey, wait a minute. Y equals 2x minus 2 must be the solution, because it satisfies everything. Dy dx came from, well, it came from here. It came from this expression. Where are you? It came from this expression. It satisfied that. My second derivative, I took it, I got that. Second derivative equals 0, perfect. So now that I know that m has to equal 2 and b has to equal -2. They did not put that work, not even remotely close. And I was actually confused when I saw their work. So if you guys can help me out here, you guys ready to see their work?
Wait, I'm confused.
Oh, what's up?
Because if the original equation is y equals 2x minus 2, how did they get the first derivative of 2x minus y?
What do you mean? Are you looking at? Oh, okay, I got you. How did they get the 2x minus y? No, well, we went to the second derivative from the 2x minus y. If you want to do, let's see, the first derivative is 2. Okay, but this is one solution for dy. The dy dx is 2x minus y. This is going to help you do your slope fields. So a solution that we have, so I think maybe I confused you. The y equals 2x minus 2 is one solution of many possible solutions. It's a linear line only when the second derivative is 0. But if the second derivative is not 0, like in quadrant 2, how they're all concave up, every solution in concave 2 is not a linear line.
Oh, okay. So there's multiple original equations.
There's an infinite amount that satisfy dy dx equals to whatever the equation was, and where the second derivative is still 2 minus 2x plus y. But this specific one, where is the second derivative 0? Well, the only time that I have a linear line on this slope field is when I have this particular equation that will satisfy the dy dx and the second derivative equals 0. Does that make sense?
Yeah.
Yeah, there is an infinite amount, guys. So remember, hopefully you guys remember from the last 2 times, all the slope fields that we put in all the different equations. All right, so here we go. Let me show you the solution that these guys got. And to me, it doesn't make sense, but maybe, I mean, I'm sure if I invest some time, it'll make sense. But it didn't make sense initially to me. I would have to invest some time. All right, so let me show you what they got. All right. Is that this one? Yeah. Okay. So letter A, I think we got that correct. It was 2 points. It's always going to look the same, guys. It has to, because that's the only way we can do it. Letter B, it's always going to look the same. Well, more or less, right? Maybe you described it in words. Maybe I like their explanation better. I like my explanation better too. So there it is. 2 minus 2x plus y. So they give you 1 point for that. And then 1 point for the concave up with reason. In quadrant 2, x less than 0, y is greater than 0. So 2 minus 2x plus y is always positive. Therefore, all solution curves are concave up in quadrant 2. So you do not have that linear line in quadrant 2. And it doesn't go through that quadrant 2 at all. It doesn't even touch. All right, letter C. There it is. Perfect. Therefore, f has neither a relative min nor a relative max at x equals 2. Perfect. Look at letter D. I would never have thought to go that way. And to me, honestly, right when it gets to here, I get lost right here. I'm a little confused. I'm sure if I invest some time, I'll figure it out. So let's see. Y equals mx plus b. That means that the derivative of mx plus b is m. So yes, so that's a true statement. The slope is m. And then they said dy dx equal to m. Okay, that makes sense, because that's what dy dx is. This is where the little manito is, manito, I don't know, whatever you want to call it, with a little hand, where the 2x minus y, that's dy dx, and they're setting it equal to that slope. Yeah, okay, that makes sense. Then they write 2x, and then where it says y, they're replacing it with mx plus b. So that's substitution, that's fine. It still equals that slope. Okay, I get it. Then they did this. So I see what they did. They moved the end of the left-hand side. They distributed the negative. And so they get 2x minus mx. It factored out an x, 2 minus m. And then factor out a negative, because you have minus b. So negative n minus b, factored out the negative, m plus b. I get it up to there. And then they said 2 minus m has to equal 0. Okay, how? How do you know that 2 minus m has to equal 0? I don't have a common factor there. 2 minus m, 2 minus m. Why must 2 minus m equal 0? Can you guys tell me? I don't see it right now. Off the top of my head, I don't see it, unless I'm missing something. I would have never done it this way. They told me that 2 minus m equals 0, so m equals 2. I want to know why. How do we know that 2 minus m has to equal 0? Because I do not see it from this line here. I don't see it from that line, how the 2 minus m has to equal 0. And then from there, oh, I'm sorry, go ahead.
I wonder if they did the last 2 lines at the same time.
So maybe they did a system of equations.
Yeah.
2 equations, 2 unknowns. Well, the way they're doing it looks weird to me. So yeah, I mean, I guess 2 equations, 2 unknowns. ddx of mx plus b equals m, that was 1 point. 2x minus y equals m, that was another point, connecting the dy dx to that m. We didn't do that route at all. I just set second derivative equal to 0. So I got my equation and I got my answer. I think I don't want to say 100% sure, guys, but I am pretty confident that what I did would have been full credit. Because at the reading, there's several rubrics. There are several answers that are accepted. And it is valid. Calculus work is calculus work. A linear line has a second derivative equal to 0 because they have no concavity. So I'm pretty confident that they would have taken the answer that we wrote. I do not like their route. It looks to me like they created a system of equations and then solve for m and solve for b. I don't like that route. I wouldn't have thought of that. But maybe, do you think you guys would have thought of this route? Would you have thought of the second derivative equals 0 route, or not either because I told you? Now maybe you're thinking like, maybe I will think of that. It comes with experience, guys. The more you do these, the more that you'll figure it out. So good thing that you're here. You're getting that experience. I would not have, I can tell you right now, I would not have gone that route. Even if I were a senior in high school taking this class, I don't think I would have gone that route either. I think I still would have gone, oh, concavity is 0 because it's a linear line. So second derivative equals 0. Oh, look at that. I have an expression already that's a linear term. Bam. Hold on, guys. I'm getting a text message here. Oh, okay. Yeah, I will. All right. So yeah, I would not have gone that route, guys. I see what they did. I would not have gone that route, but I think we would have gotten the full credit. Okay, that was fun. Let's go back. Did you guys not have fun with that one? Okay, sorry. I had fun, guys. All right, this question here I took from Mr. Scott Pass. He's a very successful calculus teacher somewhere in Austin. I forget the school. Initially, I liked him. Like, I liked this, so I can't take credit for it. It's his work. Initially, I liked it. But then when I did it the second time, I'm like, I don't necessarily like it as much. But you'll see. Maybe you guys will like it. I don't know. So I just wanted to tie everything up together. So I was hoping that when you were in Algebra 2, did Ms. Lanford, did you get a chance to do a whole bunch of these in Algebra 2 or no?
I think we did. It looks familiar.
Godinez, what about you? Did we do like a lot of compounded interest? And do you remember this formula? P e to the RT?
We did them, but
No?
I don't think we did all.
Okay. So I'm going to have to talk to our Algebra 2 teacher or Algebra 2 team and talk about this because this is something that we should already have some experience with. All right, let's go ahead and get into it, guys. The population of a town is given by an exponential equation. P equals 4123 e to the 0.02 t, where t is measured in years since the beginning of 2010. Okay. Letter A, determine the initial population in 2010 and the initial instantaneous growth rate. All right. If you have experience, I would hope that you remember that 4123 is your initial amount. If you do not have experience, then you're probably going to do this. P equals 4123 e to the 0.02 times 0 because I want the initial. Want initial. And initial is always indicative of time equals 0. Anything raised to the 0 is 1. So I have 4123 times 1. So 4123 is initial population. This is just algebra. If you had algebra already, you would already know that amount or that constant in front is your initial. No big deal. Then it wants us to find the initial, it wants us to find an initial instantaneous growth rate. Okay, so dp dt, I gotta find the derivative, is 4123 e to the 0.02 t times 0.02. And then I'm gonna plug in time t equals 0. And again, I'm gonna get 4123 times 1 times 0.02. And what do we get there? 4123 times 0.02. I got 82.46. Initial instantaneous growth rate. And this is, I need units. Well, they don't tell me units, but if you wanted to put units, it's people per year. People per year. I hope I didn't make any mistakes. I don't see any initial mistakes right now. So I think we're good. All right. Letter B. Write a differential equation for the growth rate of P at any time T. Okay, well, I already had it. It's this guy. So dp dt is equal to, and let me go ahead and multiply 4123 times 0.02, which I think was this. Well, hold on. Notice that within the differential equation, we'll find multiple. Okay, let's not do that. Let's just write it out like that. 4123 e to the 0.02 t times 0.02. And then it says, notice that within this differential equation, you will find P multiplied by some constant. Yeah, I see that. This is P. Rewrite the differential equation in terms of P. So dp dt is equal to 0.02 times P. All right, here we go. I don't see, I rewrote it. I'm good, I think. Letter C, determine another exponential relationship in which the differential equation in terms of P is the same as in part B. What do you mean? Do they want another equation? Determine another exponential relationship in which the differential equation in terms of P is the same as in part B. How do you transform the graph of P equals? Okay, well, I think maybe they want me to get another P then. So let's start from here then. So dp dt equals 0.02 P. I'm going to separate the variables. dp over P equals 0.02 dt. And I'm going to integrate integral. ln, absolute value of P, is equal to 0.02 t plus c. Next, I'm trying to solve for P here. E. And I guess right now I'm going to keep writing the absolute. E to the 0.02 t plus c. That's a t there. Now remember, side note, e to the m times e to the n is equal to the em plus n, and this is exactly what I have right now. So I'm trying to go backwards here. So I'm going to say absolute value of P is equal to e to the 0.02 t times e to the c. Okay, now this is just some constant. So now I have P, notice that I didn't put absolute value, is equal to C e to the 0.02 t. And look, how do they look the same, or how have I transformed it? All I need now is give me an initial condition and I can solve for what C is. Obviously I know that C is 4123, but now you can solve it for any initial condition. That's kind of cool, right? Or you're not impressed? Aleman, you're not impressed? They're like, I'm not impressed with this, Chavez. Write a differential. Oh, what's up? Ask.
Wait, why did we just do that?
Well, I mean, unless I understood the problem wrong, it's possible I'm wrong, and maybe Scott Pass meant for this to not be that. Determine another exponential relationship in which a differential equation in terms of P is the same. So if I take the derivative of this, I get this guy.
Oh,
But how are they different? Well, they're different because this one is waiting for an initial condition, and it's the same as this one. Well, I guess the same as the original here. It's the same as that, but except I don't have that 4123. I just have a C. That's how I understood it. Does that make sense?
yeah, I guess.
Yeah, I'm not. Yes, you are 100% right, Godinez. I am not 100% convinced with what I just wrote. This is what I assume that he was trying to say. I could be wrong. Maybe Mr. Scott Pass, I'm going to forward you my video. If you see letter C, or I'm going to tell you to look at letter C, let me know if I'm 100% wrong. I will accept criticism. Here's what I understood. Like, I want the same differential equation. Well, if I take the derivative, I'm going to get the same equation, the dp dt. You know what I mean? And then it says, how does it differ from this graph? Well, it differs because now I don't have that number, the 4123. Does that make sense, Godinez? Okay.
I mean, it makes sense. I don't get the point of it.
Yeah, this is why I said I'm not too thrilled about it the second time around. Letter D says, Write a differential equation for the rate of change of general exponential function with base e, initial value a, and growth rate k. So anytime you have something like dp dt equals kp, it's always going to look, always going to look like a e to the kt. That's what they were trying to tell me. So you don't have to do the calculus every time. That's what they're trying to tell me. As soon as you see this, you just go right to that. You don't have to do all this work on letter C over and over and over and over again. Does that make sense, guys? All right, so let's flip the page. Ooh, so now they change it up on me. Now they say, solve the differential equation dp dt equals 0.15p for the particular solution that has initial of p equals 225. Okay, again, if you recognize it, does this look like this? Then as soon as you see that, you can go right to the answer. P equals, what's the initial? Did they give it to me?
225.
225 e to the
0.15.
0.15 t. You got to recognize it. If you do not recognize it, then you have to go from scratch. So we're going to do that. Relax. So let's see. Look how simple that was. We just recognized it. We just wrote it out. So let's go from scratch. Divide by p. So dp over p equals 0.15 t. Oh, dt. And I'm going to integrate to get rid of the dp and the dt. ln absolute value of p equals 0.15 t plus c. E caret, and I'm going to write it over here. That is absolute value of p equals e to the 0.15 t times e to the c, because remember that is just some constant. So we let the p be absorbed by the constant, e to the 0.15 t, and we know that at time 0, the amount I have is 225. So look at everything we have to do if we don't know it. 225 equals c e to the 0.015 times 0. So 225 equals c e to the 0. Yes, I know I'm exaggerating it. 225 equals c. So now let us know that 225 is c. P equals 225 e to the 0.015 t. Wouldn't it be easier if you just recognize it and just write your equation right off the bat? Yes. Same. It's just easier if you just recognize it and write your equation right off the bat. All right. And then I give you some notes. Read that, please. And if you, oh, sorry, you guys are still reading. If you guys remember from Algebra 2, so look back at your notes when they talk about money, and hopefully you'll have some notes that say the amount of money in your bank account is equal to the amount that you started with initially, E raised to the rate times time. Sometimes they call it PERT, the Pert formula. So that's where it comes from, guys. But of course, when you're a sophomore or a freshman, they can't tell you all the calculus behind it. But now you know. Isn't it awesome that now you know where all these formulas are coming from? Yeah, I think so too, guys. All right. And that's it. We have tackled every type of, well, almost, like we have tackled 99% of what type of problems that people can throw to you. We have done 4 lessons on differential equations. We've done more, but we've focused the last 4 lessons just on differential equations. Do you feel like you're getting a quality education, guys?